ownCloud Mesh. It's not a software project. It is a dating protocol for computers. So, you know, computers need to meet each other as well. If we want the world to be federated, then we need to establish these meshes and federation. So it's not about what computers do when they talk about each other. It's how computers meet, how they start the context. And the hard part, so the easy part for computers to meet is, yeah, you just use the domain names, right? You know the domain name, you know that computer is there, you know how to reach it. And especially if you use HTTPS, then you know you're talking to the right computer. Now the hard part is to know which computer to talk to in an evil internet. So how do you know, how does the blue flower who wants to talk to computers on the internet, but is very scared and small in an evil world, but still wants to talk to the pink flower, how do they find each other? So I'll answer that later. The other thing that ownCloud Mesh does, apart from establishing the first contact, is to exchange user identifiers. So it's not just the identifiers of the servers to say, hey, hello, I'm such, hey, nice to meet you. But also, at some point, you want to talk about the users that use each of those servers, because you want to start sharing. These users want to share documents with each other. They want to collaborate. So you have to say, oh yeah, I'm looking for that user on your server, and you need to refer to resources that they then share to establish the sharing of those resources. So the sharing between the users who want to collaborate with each other requires that you establish trust between the computers. And usually we think of ownCloud Mesh as a way to just, ping a user, but recently we've been working on it a lot and evolving the protocol, and we see it now more and more as a way to establish the trust. Because, yeah, it looks so simple. One user clicks share with in their file system, in their cloud server, and they say, yeah, share this with user at host, and then it's federated. Something like this, right? You type here, this is an ownCloud server, and you type here, I want to share this with Einstein at nextcloud1.docker. This is from our test environment. Yeah, you want to share this file with somebody at another server. And the user who is the recipient gets notified. And there'll be a dialogue. So in this case, it's a Nextcloud server says, hey, do you want to add the remote share, blah, blah, from this person at this ownCloud server? Now, there are a lot of vendors who implement this. I hope I got all the logos right. They are doing the main work of ownCloud Mesh, right? Because that is the actual implementation. And they can test, that like, is it working? And a lot of it is manual testing. Oh yeah, it's working now, new version, etc. But we're also doing some work on the documentation and the protocol and the test suite, which has been funded originally by Jong, then by the Science Mesh project. This year it's funded by NGI and LNet. That's the name you hear a lot at FOSDEM. And we're hoping that maybe EOSC will fund it going forward. Yeah, take a picture of that. Thank you. So one of the things we're doing this year is we wrote down the spec as an internet draft. And we tried to make it written in such a way that it's strict and clear what it means. So not necessarily easy to read, but when you do read it, then it should not be confusing. And there are a number of ways you can do ownCloud Mesh, and I'm going to talk through them. The first one is share with. I always call it share with. So that is the one we saw earlier. Marie says, yeah, share this document with Einstein, and types in the name there. She knows Einstein's ownCloud Mesh address. And then Einstein gets notified and clicks accept. And what happens after that is no longer part of the ownCloud Mesh protocol. But probably Einstein will get a link saying, oh, here you can find this file, which is actually remote. And then these servers, for instance, talk to each other with WebDAV. It could also be any other kind of resource, right? It could be you're invited to a video call, and then a video call is established. It's openCloud Mesh is just about establishing this this contact in a trustworthy way. The second one is this, and this is not strictly described by the protocol, but it's a use pattern that you see in practice, is when somebody creates a link, you can, from several EFSS systems, you can create a link like this. You say share link, yeah, and then the link is copied, and then you can give this link to other people via any transport, and then this other person can click save, and that's a really nice feature. So you're viewing, in this case, you're viewing a file that's on a Nextcloud server, and it says here, add to your Nextcloud. It should actually say add to any server, add to your server. And then you type in your own openCloud Mesh address here, and then it gets saved to your Nextcloud. You log in, then you see it, oh yeah, I saved this to myself. So that's a nice way of doing openCloud Mesh, but there the recipient actually types in their own name. So, and the next thing I want to talk about is something that was sort of developed in the Science Mesh project, and that's about a way in which we can make this scary internet less scary for the computers who want to establish contact. So for these two computers, these two flowers to find each other, the key is that these computers have users. And these users, this user trusts this computer, and that user trusts that computer. So that's information, and that's information we can bootstrap from. Because actually what we're trying to do, the users are trying to collaborate. So this user can send an invite to the other user via email or WhatsApp or Signal or whatever. And that way, the servers know which servers are trustworthy, or at least they know, like, one of my users knows one of the other users who trusts that computer, and they want to collaborate. So this user is asking me, hey, can I collaborate with the computer of this other person? So that's a service I'm now giving to this user, and so that's why I'm trusting through my user, through the other user, that server. And I know it's probably not an evil user, or, well, maybe this person is mistaken and clicked a phishing link. But as long as the relationship between the humans is trustworthy, then the servers can trust each other through the human link. And that's how openCloud Mesh invites work. Because when this user clicks accept, then there's a backend call between the servers where they establish trust between the servers. So that's how you do it. That's how you establish trust between the computers using the trust that exists between the people. This is what it looked like in, I think this is OSIS. The first user generates an invite. Just the button, generate invitation. Then there's a little step that's a little bit hard, and that's also why we need something like EOS probably to help there. To get the invite, to accept the invite, the basic way is to paste it, to type it here. But there are two parts of it. You have a token and a provider, so that's a bit tricky. You would like to have a beta, like a where are you from page, that makes this easier. But we're still working on that, making that easier. So I'd like to talk through the, to get technical. This was the non-technical part. So I just want to talk through how all of this looks in a swim lane diagram, I think. So suppose that Bob wants to add Alice as a contact and sends an invite token all the way to Alice. Now this is out of bounds. This might even just be talking, saying write this down, etc. They might be talking on the phone to each other. And then Alice says, yeah, I want to talk to Bob. And that's how the initial trust is established. the invites help the servers trust each other. So then Alice's server makes a backend call, post invite accept with the token to Bob's server, and Bob's server checks the token and says, oh yeah, this is something that Bob sent, so now I know that this server is trusted by a human who's trusted by one of my users. And this server then gets a response with some data about Bob, saying, yeah, okay, actually this is my identifier for Bob, and this is his first and last name, for instance. And then Alice and Bob can have each other in their address book, and that's nice for the servers, but also for Alice and Bob themselves. So invites are important for security. That's what we sort of found out. Another thing that's really nice is request signatures, which is being added, and in request signatures on HTTP calls use a public and a key pair, public and private key, to sign, to add a header to the HTTP call to sign it, so that you know that a HTTP call comes from a certain, it comes from an HTTP client, but that it's running at the, it's part of this, a certain server domain name. So that's how the server can know, oh yeah, you are, you can see which IP address it comes from, but then you don't know whether it's linked with a real actual server and what that server's domain name is, but through the request signatures you can make that link. And I tried, look, I had very complex ideas about how we could make openCloud Mesh be more like OAuth and more secure in that sense. And then when Maxence said, hey, let's do request signatures, then I thought, oh, wait, if we do request signatures, then all we actually have to add after that is something like the authorization code flow that OAuth already uses. And that suddenly made it much simpler. So then we specified the authorization code flow. It's in the internet draft. Nobody implemented it yet. I'm hoping CERN is implementing it soon. Because there you can use a signature to obtain a token to then do the resource access. That's better than how openCloud Mesh works now. Most actually, the way it's used now is in the invite there's a secret included, and that becomes the access token, which is, you know, it's safe, but it's not up to modern standards. So that's why we think that in the invite there can be, first of all, that needs to be a signed request, and second of all, the nonce that's in there should just be a code that needs to be exchanged, and then you can see that the party that's exchanging that code is actually the recipient who you wanted to send the access to. So there you have a second check there. And then you give out tokens which can be short-lived and refreshable. So that's sort of basic 101. Without that, we're not even talking about security for like OAuth people, etc. So that's why we want to add these features to openCloud Mesh, and we hope we can get those into all the implementations. So which this is the part I already showed. After that, there is a capability discovery. There might be different capabilities for different servers. So we added it used to be called /OCM-provider, and we renamed it to /.wellknown/OCM. There's still the fallback to the old path, but this is just a little bit neater placed. And there you can discover the API endpoints, also the capabilities of that server, like which features does it implement, and its public key, which you will need for the request signing. So that's the discovery. You start from a domain name, and then you look up the well-known, and then you just get some JSON with the information. After that, you do the actual OCM share call, the share creation notification. So here, this server does a signed post to /OCM/share to that server. And then the new thing, if there was an invite flow, which is optional, but if there was one, then you can check the invite like, hey, is this person who is sending something to my user, is that actually a contact that was established through an actual OCM invite. After that, this server will do a lookup to get the public key with which to check the signature. And then if those checks pass, then the share is created, meaning that the receiving server says, yeah, thank you for sharing this resource, and I will notify my user. After that, and this is a step that we invented, but that nobody implemented yet. We put it in the internet draft as the new way to go, because we like the short-lived tokens better than the secrets that last forever. So the code from this first post call is exchanged with a signed request for a bearer token. So even if you would somehow make this post call to the wrong server and they would try to exchange it, then their signature wouldn't match. So that's another safety check there. And after that, you do, for instance, a WebDAV prop find to go access the resource. So that's another new thing we want to add. That's what it will look like if all these things are added. We have a test suite that is testing Nextcloud, ownCloud 10, CERNBox, OSIS, and SeaFile for these different flows, the share with flow, the public link flow, and the invite flow. Mahdi Bahbani is maintaining that. He's doing very good work. I hope he's watching the stream. And with that test suite, we can check that different implementations of ownCloud Mesh are compatible with each other. And also, that's easier for vendors. Like if you have a new the new version of your own software, you want to check whether it's still compatible with all the versions of everybody else's software, and that's why the test suite exists. And we're now convincing the vendors to include this test suite in their own continuous integration, so that already if you're changing your ownCloud Mesh code, you can see like, oh, did I break anything? Like compatibility not only with my own implementation of ownCloud Mesh, but also with the 3 or 4 other ones. That's it. Thank you.
Thank you. We have 8 minutes for questions.
Are there any questions? Yeah.
What's the difference between the current approach, I think we've discussed it, and OpenID Connect? Because with OpenID Connect, you also have distributed authentication of a call, which in effect exchanges users. So when you authenticate in our online party, you don't actually authenticate, learn about the users. And if you send an invite to another person, he can use this mechanism to actually get access to other people's resources. If the underlying implementation supports some form of share.
Yeah. So the question is,
It doesn't necessarily require to be on the same server. It can be distributed federated.
yeah, the question is, what is the difference between ownCloud Mesh and OpenID Connect? The way, I don't know, there are probably some parts that you know that I don't know about that extra detail, but in general, when you say I'm going to federate authentication with OpenID Connect, that means that you allow other identity providers to provide users to access resources on your server. So that is, for instance, what it's the same with like federated SAML, like EduGain. A lot of universities use that. Like if you want to log into CERN, you can log in with your identity from the University of Helsinki. As far as I know, OpenID Connect does not have a mechanism to then also copy a resource to this other server. So,
You said that that's also nothing that Cloud Mesh is the server. Or are you
Yeah, so in OpenCloud, sorry, the question was, you said that there's only also this exchange. So in OpenCloud Mesh there are two users involved. So Alice can say, I want to share this with Bob, and then Bob gets a notification in his own server. That's not something OAuth can do, as far as I know. So Alice could say, I want to give Bob access to it as sort of an access control list, and Bob can come to my server to access it and authenticate with his own IDP. But that's different from sending a notification to his server, where in his server he will get a pop-up saying, hey, something's been shared with you, and that is actually a server-to-server access.
But you also showed, I'm sorry for taking time, but you also showed that you need to somehow exchange the contact and trust between users beforehand. So if I now send an email to a friend, and then he can follow a link there, he's automatically connected, then log in.
Sure. Yeah, so the question is, so you have to share it via email. It's true that if I want to share a file with you, I'm going to send you a link via email, then this might as well be a link on my server, and then where you can log in with your IDP. But that still means that you need to visit my server with your browser, right? And maybe that's not what you want to do. So maybe you want to have it, you have a resource in your own server. The idea of OpenCloud Mesh is that everybody looks at their own home environment, and that these home environments talk to each other. So that's where the architecture is slightly different. But you're right that they're very similar. And the important part of this is, I think, that both OpenID Connect and now also OpenCloud Mesh with these new features use the same ideas of like exchanging that come from OAuth. So that's why. That's what we do get from that, saying we think of OpenCloud Mesh as something that also fits into the OAuth framework in a way. Thank you. Maybe one.
There was one question here.
Yeah, I want to ask about the capabilities. Do you have other examples where you use
Yeah.
What else?
Yeah. The question is, are there any examples of capabilities? Well, there is one thing is the type of resource and the access protocol. So the default one is just a file or a folder accessed via WebDev. But you can also use it, and I think Nextcloud Talk does this, to establish a video call, for instance. And you could have any type of resource. You could say, yeah, I invite you to my Jupyter notebook or something very application specific. Those are the resource type and the protocols. But the way we use the capabilities here in the discovery is more about does it support the signatures, HTTP signatures? Does it support the token exchange? Can it enforce multi-factor authentication restriction? That's quite an advanced one that they use in SUNET in Sweden. So you want to make sure that if you share a resource with another server, that server has the same security policies. For instance, if you say this resource can only be viewed using multi-factor authentication, and then somebody is multi-factor authenticated but shares it with another person, and there that user is not required to log in with the second factor, then you have breached that policy. So that's another capability. If both servers have that capability to enforce it, and they trust each other to do that, then you have the MFA capability. But you can read the internet draft, and there's a full list. I think there are 3 or 4 now in the spec. Thank you.
Thank you. One last question. No? Then thank you very much.
Thank you.